Hi guys, in this video we will feature worksheet 3.6, Similar Triangles Practice. Now you were assigned this for homework and I thought maybe I'll give you a little nudge. So our first one, we do see a lot of numbers on triangle STW, and what we're going to do is I like to put them in small, medium, large. It appears as though they might be isosceles. So we're going to set up the proportions. I'm going to take the numbers from S to T, um, and T to W, and I typically put them in order from the least to the greatest. So we'll start out with 35, 42, and 42. Now, we're going to set up a proportion with the other numbers that we see, and I'm going to put them in least to greatest. Typically helps us to set up the proportion. I'll do 25, 30, and also 30. Now, we're setting that up at like a proportion, so I'm going to now turn that into my fractions with equal marks in between. And all that's left is to see if, in fact, these are proportionate. So what we're going to do now is reduce each one of the fractions to see if they produce the same decimal. I'll pause the video, grab a calculator. Now, I placed each fraction in the calculator, and what do you know? They all produce the same number, 1.4. So what does that tell me? That all of these sides are in fact equal to one another. Since they are all equal to one another, I can now say that yes, I can prove that triangle STW is similar to triangle ADE, could also be EDA, since it's isosceles. With what? That's right, side, side, side. Now let's try another. It appears as though we can't prove anything, right? I don't think so. Now, notice we do have the reflexive property in this one. How do you know that? Well, we actually have two separate triangles. I'm going to pause the video and draw them because there's a small one, HBC, and a larger one, H to G to I. If you separate them, they kind of look like this. And what do we see? Both of them share angle H. Good job. Now, I also notice that line BC, and we could say that over here, we could mark both of these as separate ones. Good job. Now, I'm going to need them to be together to find the next pair of angles. The next pair of angles that I see would be the angle formed from H to B to C, and I'll put a double mark on that one. And it will actually be congruent to angle H to G to I. Do you remember the parallel lines that form cut by a transversal? Imagine that H to G is that transversal, and BC could continue this way, and GI could continue this way as well. And what do we name those? That's right, corresponding angles. So our first set of angles that we have, angle H, is congruent to angle H by the reflexive property. And angle HBC is congruent to angle HGI by the corresponding angles. So what do we have here? Absolutely no sides. There's no way we can prove anything. Wait a minute. These are not congruent. They're similar. And we know if we have two, then we have them all. So we'll call this, which one? Angle, angle. What about number 3? I know that I have a pair of vertical angles. There's one here. It's formed by angle LNM is congruent to angle PNO. But I'm noticing something. I do have an angle in two sides. But are the sides on either side of the angle that we just wrote down? I don't think so. Do you? That angle is definitely not between. Now, if we had MN over here, if we had a number over here, and NO, then we might be able to prove something. But since they're not, I'm not even going to set them up. These cannot be proven similar. This is definitely not enough information. Let's try 4. Well, I do see the same set of vertical angles. That's what we had back here. Those were vertical angles. I do see that forming from U to T to V. And I'll use a double mark since they've already used the single mark. And then from C to T to D. So this is much like number 2. And we certainly can prove this one with angle, angle. Now I'll take just a moment to write a congruency statement for, or a similarity statement for the ones that I have proven. Again, triangle U to T to V is similar to triangle C to T to D by angle, angle. Triangle BHC is similar to triangle GHI using angle, angle. And triangle STW is similar to triangle ADE. And it's okay if you put EDA on this particular one because it is an isosceles by side, 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 because all 3 sides are definitely producing the same reduced fraction. Let's try more. Now, again, I like my little technique. I like to go small, medium, and large when I set them up. So I'll say 3.5. Then I'll say 49.5. Again, I'm putting them in numerical order, right? From the smallest to the greatest. And then the last one will be 54. Now I got those all from triangle KNB. Now I'll repeat that process with triangle DFP. Our smallest number is 18. Our next number is 22. And the last, or the greatest, is 24. It's a great strategy of setting up your proportions. Now grab your calculator because it's time to see, are these equivalent fractions? When I tried 40.5 over 18, or 40.5 divided by 18, I did get 2.25. Let's try the next one. So far, so good. Let's try the last, 54 over 24. Don't make any assumptions. All three have to be 2.25 to be equal. It looks like it's a winner. All the sides are producing the same equivalent decimal. And now we know what? We can prove that these triangles are similar based off of side, side, side. Now let's try that similarity statement, shall we? Now, I could continue and name them in numeric order. Again, going from the small side, 40.5, N to B to K. You just want to repeat that and chase those letters down and make certain they're in corresponding positions. All right, so I'm just going to triple check to make certain. Again, I went from N to B to K. Notice how I'm going over the smallest side and then the medium size side. And that's why I wrote N to B to K. Let's see if we did that for D to F to P. D to F to P. Not bad. Let's try another. Now on this particular triangle, I don't see the parallel lines. So I can't do the triangle proportionality thing. I mean, where we could perhaps subtract 90 minus 40 and say between R and H is 50. Now that is true using the segment addition postulate. But as I'm looking closely, I see that I'm going to have to, I don't have parallel lines, so I don't have triangle proportionality on these sides. So what am I going to do? I'm going to add together this entire side. I'm going to add all the way from S to T so that I have matching parts in order to be able to set up my proportion. Now, if I go all the way from T to S or S to T and add 45 to 36, I now have a number that I can set up as a proportion. So here we go. I'm going to take 36 from this side and put that over 81. Then I'm going to set that equal to 40 over 90. I can then cross multiply to get the same product or simply reduce each fraction. Grab your calculator. We need to see if these sides are proportional. When I multiplied 36 times 90, I got 3,240. It's okay if you reduce the fraction, but I just decided to cross multiply. Now I'm going to repeat that and multiply 81 times 40. If I see the same number, then I'm going to move on. When I multiplied 81 times 40, I got 3,240. Looks like we're headed in the right direction. Now, if they only shared an angle using the reflexive property, I think they do. So, what do? Do you see it? I hope so. Let's mark it up. Both triangles, there's a tiny triangle from G to S to H, share the same angle using the reflexive property. Angle S is congruent to angle S. So I have enough information to prove side angle and side. Once again, we can prove that these two triangles are congruent by side angle side because the angle is in between. Angle S is congruent to angle S. That's by the reflexive property of congruence. And the sides on either side of angle S are also proportionate or proportional. Now let's try that congruency statement. Did I say congruency? No, that was the last test. It's triangle GSH is similar, let's try that similarity mark, to triangle TSR. Remember, angles are congruent. Sides are proportional. The right ones too. So triangles are similar. Now you try the rest. Be sure to look over all 6 of these to help. Make certain that if you see parallel lines, as in the case of number 8, there may be some hidden angles. Also, there may be more reflexive property here. And just because there's no numbers at all doesn't mean that it can't be proven using angle similarity. I'm pretty sure that'll be the case in number 12. Good luck.